In this video, we're going to start taking a look at some code. But before we start that, I'm going to show you what the game does look like now. So for instance, let's just start a new game here. So I'm going to click on U, and I'm going to select my favorite test image here. You can see I've got 5 different images that I can work with. These are the 5 stock images I have part of the repo, which again, just FYI, the repo is public. You can take it, you do whatever you want to with it. Give me credit if you want to, but you know, hey, if you want to use the code as is and build your own $1 million game with it, be my guest. I can do either a square cut or I can do a jigsaw cut. I'm going to opt for the jigsaw cut because it looks a little bit better. And I can do 12, 48, or 192 pieces. I'm going to opt for 12 because I'm going to show you how things are going to work, and it would just look a whole lot better and a lot easier to run the game. So we're going to do 12. We'll click on continue. There are my 12 pieces, and let's just start putting things to, First of all, we'll click on start at the very top. Now that we clicked on start, we will move the piece, and notice we got a time at the upper left hand corner here. We got a time and we got the number of moves, so I do keep up with the number of moves. All right, we've got that piece that connected up. Let's move that piece out of the way. We can pop that piece right there. That works. And let's see, pop that piece. So that one's probably going to go about right there. And let's get this piece and move that to right there. Yep, that connected up. Yep, that connected up. Good, 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 good. Let's move that piece over to here. And it looks like, I think that one goes way up here, if I recall correctly. No, it does not. It looks like it's going to go to right there. It sure does. All right, so we got this one over here. That was going to connect up to right there. And going to be kind of hard to get to this one. Let's get to that one. We got that one. That's going to go right there. This one is going to go down to here. And done that. This one's going to go right to here. Got that. Oops. This one's going to go right to here. Got that connected. As you can tell, I've got 2 pieces remaining. Start out with number 12 pieces. 2 pieces remaining. Let's go to this piece. Let's see if we can connect it in. And we're done. That's it. My time is finished up. It stopped clicking. Took me 1:23.3 seconds. Took me 35 moves. And I have 1 remaining piece. So that's what the jigsaw puzzle looks like now as opposed to the one we had before. So let's now start taking a look at some code. Okay, this is in a mono repo. This is the Fun With JavaScript public repo. And basically everything is installed within the main root. And you can access all the different games that I'll be creating here with the games. For leading lessons that we're going to be working with here over the next year, you'll have lessons. So you have access to everything I'll be discussing here. But all we're worried about now is just the jigsaw puzzle. Now, I organized this in a way that I forced myself as much as I possibly could to do unit tests first. Now, the whole idea behind unit tests is that you test everything within the objects first. You create your test and have everything to fail. So for example, if I wanted to test, let's just say if I wanted to create a jigsaw puzzle with 800 width and 600 height to have 8 columns and 6 rows, I would expect my piece to be a size of 100 width and 100 height. And that's basically the kind of stuff you want to do in tests. So let's take a look at some of the tests that we have created here. Well, for instance, I've tested the game itself, and I've tested what each piece does. So let's just take a quick look at the piece, some of the things that did a piece. The piece happens to be very, very simple here. When I create a new piece, I want to be able to have at least a position. So remember earlier that I told you that we have a position within the piece and a ordinal within the piece. And these are 2 very important pieces of information. The ordinal is static within our piece itself, while the position changes as it gets dragged and dropped. So this particular test here basically says I should expect to have a X value and a Y value, which is part of my position, and I should expect to have an ordinal X and an ordinal Y value, which matches what I've sent here. And that I'm just testing for the idea for the string itself. This allows me to test the important parts of the piece. Let's take a look at the methods one. A lot more going on here. So when I perform methods on a piece, I should move to another position. And this basically means I am going to declare myself to have a move method. And when I move it to, after I create it, after I move the piece, I should have a piece, I should have an update to XY to match what I've done here. There's also a relative move, and that's very important because if you're moving a piece, if you're dragging and dropping a piece, as you move your mouse is actually moving relative to the position it was before, and I'm just passing that relativity over to the piece. So I'm testing, so I have a routine to physically just move it from one place to another very quickly, or I have a way to be able to move it relatively, and that's also very important for all the children. We should have a checking point. The checking point is another important part of the piece that allows me to figure out whether two pieces are next to each other. And this checking point will give me the ability to say, here's the width of the puzzle, here's the height of the puzzle, this is the XY position of this checking point. And that XY position will move as the position of the piece moves also. But it's with the checking points that I do the checking to see if they're close to each other. If you remember the slideshow we done in the previous video, you remember that we mentioned that I couldn't care less whether a particular piece is a square or designed any other way, as long as I had a consistent point to be able to check. And that's what this checking point is all about. I need to be able to add a child, because remember, when I have a piece that makes a connection, I need to be able to add that particular piece as a child. I should be able to search for a child, and that's with the hasChild method. And this is a test for making sure I have a child. So I can add a child. I need to check to make sure I have a child. I need to make sure I can either find it or not find it. That's what that one does. I should be able to not find a child based upon the ordinal. Get child by ordinal allows me to either get a child. By normal, I would get a child based upon a particular piece object itself, but I may not know that piece object. I may only know the ordinal of that piece piece. Therefore, I need to be able to not only get a piece by the piece object itself, but I also need to be able to get it by the ordinal position. So these two tests allow me to test to find out whether I can find it or not find it based on the ordinal position. This allows me to be able to find out if I am a child, whether I have a parent or not. And this says I can either find the parent or I can not find the parent, or if I'm not a parent. This basically tells me whether I am a parent or not. And this will be able to report back to me that I have at least one child. This is another function called hasChildren. And this will tell me whether I have a multiple number of children or not. I can also remove a child. Once I add the child, we can also remove a child. That's what also has to be tested for. We cannot remove the child if the child is not found. That's what this particular test runs for. I should be able to add a DOM element. Obviously, with the UI, I'm going to create a DOM element that's going to contain this piece, and I need to be able to take this piece and know that I have a DOM element attached so I can do any kind of funky little DOM manipulations if need be within the piece. So I'm setting the DOM right there. Now, other dealings, we're dealing with the family of piece, so this whole section through here deals with how to get the family, because earlier I mentioned things about I needed to get the family tree of this particular piece. Well, get family is a function or a method that's going to be able to give that to me. And then all these tests are basically allowing me to be able to, are testing different permutations of the get family piece. This other piece right here allows me to be able to, once I move a particular piece, this will test whether that move has created a child or a parent. That's what all this testing is going to do here. It should move a piece when the child, when the target is a parent, when the piece is a child of a parent, when the piece is a parent, it should move itself and all the children, and so on and so forth. So each and every single one of these particular tests here does a test on the pieces to be able to determine whether once I have moved a piece, which is what the move and the move to command will allow me to do, once I have moved those pieces, this will allow me to know that connections have been made. And that's what all of these tests are for. I'm not going to go through each and every single one of them. And that's the key here, is that each one of the objects I want to test for, I want to have a test that's going to be, say, I expect this particular object to do this particular thing. All my different cuts. I have a base cut, a jigsaw cut, and a square cut. This is, for instance, the square cut. Here's all the specifications for the square cut. Here's all the specifications for the jigsaw cut. A little bit more than the square cut because I have different jigsaws. And I'm going to spend an entire video on just how I did the jigsaw one. Let's see, statistics, the thing at the statistics at the top. The table has a plethora of different tests adjusted to it here. All the different statuses. We have a number of different statuses that are, let's see, where's a good one here? Status game finished. Status connected. This is basically once a piece has been moved, what is the status? Well, we'll send the status game finished once there are no more pieces available. We will send the status connected once there is a connection available. Status moved means that we have taken a piece off the floor and moved it to a more particular place on the table. Status no change basically means, hey, you moved it, it's fine, everybody's cool with it, stuff like that. Adjustments, basically once a piece has been moved, you drop a piece off the table, and once you put it back on there, we need to make sure that those adjustments have been done correctly, and that's what all these tests do. The methods test tells me, I should be able to how do I cut the puzzle? How do I shuffle the puzzle? How do I get I should have an ID. The giant one in this entire thing, and it is huge, is the connections one, because I've got to test all those different connections. If you remember in the PowerPoint video, I showed you all the different permutations I could think of how children can connect with parents, and multi-pieces can connect with single pieces, and single pieces with multiple pieces, and blah, 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 and so on and so forth. That's what this entire thing does here, the connections. It is giant-sized. It is huge, but it tries to take care of each and every single possible permutation that I can think of. For instance, this one right here. Let's see. And when I had, let's see, what are we testing for? Blah, 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 blah. When I work with multi-pieces, where was that other one? Could look pretty, yeah. And when I have a multiple independent connections, I should make the correct connection. So I got a set of 2 here, I got a set of 3 here, and I got a single piece. And then I move one of the pieces. And so I've got to check to make sure actually every one of them has the correct children, has the correct child, has the correct children, and blah, 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 and so on and so forth. So do you want to see it running? Well, so do I. So what we'll do is we'll flip back over to our screen. And then we will start the test. Let me make sure I've got everything set up here correctly. Nope, I don't. Oh, yep, I don't. I'm missing something. All right, let's get that running. Cool. All right. Now let's run the test. This is, by the way, we're using Cypress here. All right, make sure everything's okay. Okay, so you should see, yep, there's the Cypress screen. So we're going to do our EDE testing. And we're going to do the interactive version here. So we're going to start EDE testing in Chrome. There it starts the test. And there you can see all the different tests that we have. These are the different tests that I just showed you about, or told you about. For instance, if we run cut base here, these are the tests for the cut base. There we go. And it's all finished up there. Or if I wanted to test all the different pieces on the jigsaw, there it tested all the different pieces of the jigsaw. Remember when I said earlier that the table connections was huge? Let's go down to table connections. There it goes. It's all done. Every one of these things. When I check for the directional connections, when I drop a single piece, when I work with multi-pieces, and I connect with a single piece, and I connect with a child of multi-piece, and I connect with a parent of multi-piece, and when I have multiple independent connections. All these things have got to be checked for, and as long as you have taken into account everything that you wanted to take into account on your testing, you can test each and every single one, and all your tests run, then your code is okay to play with. Well, that's a good one here. I don't know it's a good one because we're kind of just, this is also very good, by the way, for EDE testing. I have not completed my EDE testing here yet, but you can see it's starting to do some things. As you can see there, it does have a couple little errors, but that's okay. Because that's actually one of the things that I'm going to do. Oops, still going. That's actually one of the things that I wanted to do in another video. Once we go through this video, is to show you exactly how to implement all the EDE testing on this. But that's for another day. But the core thing here is that if you remember correctly, on our PowerPoint display, I showed you that the games and the table and the UI were separate. And I did that so I could have all of these different tests and make sure absolutely everything works before I even got to the UI part. So for our next video, what we're going to do is we're going to take a look at the code part of it. And that may take a number of different videos, but I think you'll enjoy it. Thanks for watching. Subscribe to this channel to view more videos. Click on the like button on this video and visit us at TheVirtuoid.com. Also, support us on Patreon, where you can get access to member-only videos. Links are down below. Again, thank you very much for watching, and keep on coding.